Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to discuss about module 8, which explains decrease and conquer algorithm design strategy. In this module, we are going to discuss about two topics. The first one is algorithms for generating combinatorial objects and advantages and disadvantages of decrease and conquer method. In this session, we are going to discuss about algorithms for generating combinatorial objects. Now, generating combinatorial objects involves creating various combinations, permutations, subsets, partitions, and other arrangements of elements from a given data set. Depending upon the specific type of combinatorial objects you want to generate, different algorithms are used. That is, if you want to generate permutations, you need to use different algorithms. If you want to use combination, if you want to generate combinations, you have to use different algorithms. If you want to generate subsets, you have to use different algorithms. So like that, every type, based on the type of combinatorial object that you want to generate, you need to use the algorithm. Right. So here in our syllabus, we are going to explain about two different combinatorial objects. Those two are, first one permutations and second one combinations. So first we are going to discuss about generating permutations. Now, what is meant by generating permutations? Generating permutations involves creating all possible arrangements of set of elements. Generating permutations means it involves creating all possible arrangements of set of elements. So for simplicity, if you want to, let us assume that you have a set of elements whose permutations need to be found. That set of elements are lying from 1 to n. More generally, they can be represented as an array from A1 to AN. Now, what would be the decrease and conquer technique that we will be suggested for generating the combinations? So here, how many combinations may be there from 1 to n? There may be n factorial permutations that we can generate of 1 to n elements. So here, first step, as the first step, we are going to do the smaller by 1 problem is used to generate the n minus 1 factorial permutations. That is, if you have the elements from 1 to n, that is, the elements are represented 1, 2, 3, so on n. So if I want to generate the permutations of all these elements, I will get n factorial permutations. Right. Now, for generating all these n factorial permutations, we are using this decrease and conquer method. So, in the decrease and conquer method, especially we are going to use decrease by one technique. So that is, we are going to make the problem smaller by 1. That is, we are going to make n minus 1. That is, if I take n minus 1 elements, 1 to n minus 1, I need to generate n minus 1 factorial permutations first. For all these n minus 1 factorial permutations, I am going to include n, right? So then, by multiplying that n with n minus 1 factorial permutations, I will get n factorial permutations. Like that, every time we are going to use this smaller by 1 problem type or decrease by 1 technique, right? Suppose, let us see, if I have only 1, 2, 3, how I can get different permutations for this. First, we are starting with my n is 3, right? So, since my n is 3, I am going for n minus 1 factorial permutations first. N minus 1 means 3 minus 1, that is 2. Again, for getting the 2 factorials, I need to go for again n minus 1 factorial, right? That is first n elements I have. So for this n element, I need to get n factorial permutations. From that, I am going to take first n minus 1 elements from this n. I need to get n minus 1 factorial permutations. Again, from this, I am going to decrease one more, that is n minus 2. So that is, we are getting n minus 2 factorial permutations. In the same way, if we are like that, if we are decreasing, finally we will get 1, which will give 1 factorial permutations. That is only a single permutation is there for that element. So like that we are following. Since we have 3, I will get 3 factorial permutations. Now, for getting these 3 factorial permutations, I am using decrease by 1 method. So that's why first I am decreasing n by 1, which it will give 2. I'll get 2 factorial permutations. So for finding these 2 factorial permutations, again I am going for decrease by 1 method. That is, my n value is again decreased. That becomes 1. So it gives 1 factorial permutations. That is, only 1 value is present. Right. So in that case, I'll get only 1. Right. So insert 2 into the 1, right to left. Now, first I inserted 2 at the right. Next, I inserted 2 at the left. Then I will get 2 permutations. That is 2 factorial. 1, 2, 2, 1. 2 permutations are there for the 2 elements. Next, insert 3 into 1, 2, right and left. Now, here 3 is inserted at the right. 3 is inserted at the middle. 3 is inserted at the left. 3 is inserted at the left. Like that, I get 3 permutations. Now, insert 3, 2 to 1. Now, here, since you have only 1 here, right and left you inserted, right? But here you have 1, 2 and 2, 1. You need to insert 3 from right to left in 1, 2 as well as in 2, 1. Right. Now, here 1, 2 is used to insert 3. Here 2, 1 is used to insert 3. Then finally here you will get 3 permutations and here you will get 3 permutations. Totally 6 permutations you got. So for the given 3 numbers, 3 factorial permutations are there. 3 factorial permutations means 3 into 2. 3 into 2. That is 3 into 2 means 6. So totally you will get 6 permutations. So we will get the 6 permutations for my given set of elements. Right. Now for this we will get we have 2 methods for finding the permutations. So the first algorithm is heaps algorithm for generating the permutations. So here you can see the heaps algorithm here. So here it takes 2 parameters, A and size. Now how heaps algorithm works means, if size is equal to 1, then just simply I need to print A. For I in range size, now again we are recursively calling the heap permutation for size minus 1. For size minus 1. So if size modulo division 2 is equal to 1, we are going to swap the elements. If A of 0 and A of size minus 1. Else, if it is not correct, we are going to swap the elements A, I and A of size minus 1. Now, how this algorithm can be implemented? Let us see the example of implementing this algorithm. So here you can see the implementation of this algorithm. How it is implemented. Now, I have given 1, 2, 3. So I want to use heaps algorithm for getting the permutations of 1, 2, 3. So initially I called the algorithm for 1, 2, 3, whose size is 3. Now since 3 is equal to 1, which is false, now for I is equal to 3, we are calling heap sort of, again heaps algorithm we are calling heap of 1, 2, 3, comma, for size minus 1 we are calling. So you already remember that here I need to call the algorithm for size minus 1. So that's why we are calling the algorithm for size minus 1. Here size is 3. So we are calling algorithm for size minus 1, that is 2. Now, since 2 modulo division 2 is equal to 0, we swap A0 and A size minus 1. So that is these 2 are swapped. So 3, 2, 1 I get. Right. Now again, I is equal to 1. When I is equal to 1, I call the algorithm again for size minus 1. But here, my heap, my array, initially my array is 1, 2, 3. But when I swap the element, my array becomes 3 to 1. So I need to call the algorithm for 3 to 1, comma size minus 1 is 2. Again, here also my modulo division operation becomes true for 0. So here swapping is done. Right. Here after swapping, my array becomes 3, 1, 2. So after that, for I is equal to 2, I call the algorithm. So here, how many values I am calling the algorithm? For I in range size. Here my size is 3. That's why I is equal to 0, I is equal to 1, I is equal to 2. For the 3 values, I need to call the algorithm. Here I call the algorithm for 3 values. Right. Now again, I am going to solve this heap sort. Again, this is the iterative form. This heap sort is called. Again, this heap sort generates 2 functions. Again, this heap sort generates 2 functions. This heap sort generates 2 functions. Again, these are to be individually solved. When I solve these individually, I get the elements print 1, 2, 3, print 2, 1, 3, print 3, 2, 1, 2, 3, 1, print 3, 1, 2, print 1, 3, 2. That is, all these print elements are coming, which gives the different permutations by using this heaps algorithm. Right. So if you see the next algorithm for generating the permutations, it is called as Janssen-Rotor algorithm. So here, what Janssen-Rotor algorithm tells, this algorithm is used for generating the permutations. Here A is a positive number. A list of all permutations of 1 to n should be generated. So how this algorithm works? While the last permutation has a mobile element, do find its largest mobile element k. Swap k with the adjacent element k's arrow points to. Now reverse the direction of all elements that are larger than k, add the new permutation to the list. These three steps are to be implemented recursively. Then we will get all the permutations. Here you can see the example. So initially I have 1, 2, 3. The largest element is 3. Now I am going to find the next element which is present pointed towards that arrow, that is 2. Now this largest element is swapped with 2. Then after this largest element, the next element in the arrow pointed direction is 1. Now 1 is swapped with 3. I will get next permutation. Now here I'll find that there is no another element to swap with 3. So that's why its direction is reversed. Now the direction of 3 is reversed. Now we find in this direction, the next element that I found is 2. 2 and 3 are swapped. Now the next element I found after 3 is 1. 1 and 3 are swapped. I'll get this permutation. So here you can see all the 6 permutations are obtained simply by finding the largest largest element, and its next element in the pointed arrow direction, and by swapping operation. So this algorithm tells Janssen-Rotor's algorithm for generating the possible permutations. So I hope that you all understood the heaps algorithm as well as Janssen-Rotor's algorithm for finding the combinations, for finding the permutations. Right. Next, we are going to see combinations. What about the combinations? Now, generating combinations. What is a combination? The combination is a kind of arrangement of some given objects. So in mathematical terms, combination is a set of choices or selection of items from a unique set of objects. Suppose, for example, you have a bag with 5 different colors and ask to generate a pattern with any 3 colors. So you can also pick any 3 colors out of 4, or you can also pick any 3 colors from out of 5, right? Like that. Suppose, for example, here I have given 5 colors R, G, Y, B, I. So here R is red, G is green, Y is yellow, B is blue, and I is indigo. Now, so the possible patterns for 3 colors are RGB, RGY, RGI, or YBI, GYB, like that. Okay. Suppose, for example, if you given any fixed value with R, what the combinations that I get means, I can write RGB, RGI, RGI, or RBI, or RYB. Like that, I can generate different combinations with R. So I can use a fixed element, or I may not use the fixed element. Now here you can see the example for that. So here I given 5 colors. So from that 5 colors, taking 4 colors combinations. Now RG, YB is one combination. RG, YI is another combination. RG, BI is another combination. RY, BI is another combination. And GY, BI is another combination. Because, for example, if I want to find the combinations from these 4 elements, I can get the combinations from the four elements, three element combinations from that four elements. So here I can get four combinations. Like that I can get a number of combinations. Now here you can use this formula for getting the combinations. NCR is equal to, here N is the total number of elements, here R is the number of elements that should be present in the combination. Now, how many combinations that I get means N factorial by R factorial into N minus R factorial. That is, suppose, for example, if I have 5 colors, with the 5 colors, if I want to find 3 color combination means how many combinations that I can get is 10 combinations that I can get. Now, here I already said you that I can use fixed element combination or variable element combination. If I am using the fixed element combination with recursion, now how can I get the combinations? Now here you can see RG by DI is my color, N is equal to 5. I want to find R is equal to 3. 3 color combinations I want to find. Now, how many I can get 3 color combinations means I can get 10 combinations. How those 10 combinations can be obtained? So first I am taking 3 fixed elements. So 3 fixed elements are R, G and Y. Now R is fixed here. So remaining colors can be changed. RG, RY and RP. Now here I am going to take RGY, RGB, RGI. Now that is here I am taking 2 elements fixed. So that's why things 2 elements are fixed. And I need to take the 3 combinations. Here I am taking 3 combinations. Here I'm making 3 element fixing. Right? Picking 3 elements. RGY, RGB and RGI. Next in the same way RYB, RYI. Now here I am getting RBI. Right? Now here with G is fixed, I can get GY, GB. Now GYB, GYI, GBI. Now here Y means YB only. I have YB, I3 color combination. Now here you can see totally I got 10 combinations or 5 colors of 3 element combinations. Right. So this is one method, and another method is include and exclude every element method. This include and exclude every element method follows Pascal's identity for finding the possible combinations. Now here Pascal's identity is to be represented with this formula. NCR is equal to N minus 1 CR plus N minus 1 C R minus 1. So it represents including and excluding of the terms. Now what is the step-by-step procedure that we follow for this particular method? So first we need to create a temporary array data. So one by one we need to consider every element from the input array and recursively apply these 2 cases. Either we need to include the element into the current combination or we need to exclude the element from the current combination. Whenever the number of elements is reached to R, then we need to print that combination. Now here you can see the example for this method. I want to generate 2 element combinations from the given set 1, 2, 3. So how that include and exclude method works? So initially we have taken an empty array data. So first in the first iteration I am considering 1. First I included 1 into the data. Now 1 is present in data. Now since the number of elements is not reached, that is I need to element R value is 2 here. That is I need to find 3 C2 element 3 C2 combinations. Since R value is not reached to 2, I need to include 2. Now first combination I find. Next include 3 is not possible since already 2 elements are there. So I need to exclude 2 from the combination. Then again I need to include 3. I will get the second combination. Right. So when I considered 1, here I am getting 2 combinations. Now when I am considering 2, so recursively I need to repeat the process for every element. So first I recursively called the process for first element. Now I recursively call the procedure for second element. Now I am going to include the element into the data 2. Now since the number of elements is not reached, I is equal to 2. Now I am going to include 1. 2, 1 I am getting. Already I have the same combination here. So that's why it can be eliminated. Now exclude 1. We are excluding 1. Now we are including 3. I will get 2, 3, which I will get a third combination. Now, so this procedure is completed for 2. And I am considering again 3 from the input array. Now I need to include 3 into the data. Since R is not equal to 2, I can try for 1 and I can try for 2. I'm including 1. I get a combination 3, 1, which is already which is represented in the second combination. Now I excluded one. Now I tried for 2, which is included. Again, I got the same combination in the third combination. So that's why this is also to be excluded. So from my input array, all the values are completed. So therefore, the possible combinations that I am getting are 1, 2, 1, 3, and 2, 3. Right. So this is include and exclude method. So I hope that you all understood this include and exclude method also. So here in this session, we discussed about generating permutations and generating combinations. For generating permutations, we see 2 methods, and for generating combinations also we see 2 methods. For generating permutations, we see Heaps algorithm and Grant-Rotor algorithm. And for generating combinations, we see in fixed element algorithm method and inclusion and exclusion method. So I hope that you all understood these generating permutations and combinations. Thank you for listening. Thank you.